everyone. My name is Catherine Kiaria from School of Computing and Informatics. I will be taking you through a unit known as Object-Oriented Programming, BIT3106. Welcome. So, I want us to have our lesson 1, and in our lesson 1 of Object-Oriented Programming, we are going to look at OOP overview and basic concepts. So, on OOP overview and basic concepts, I want us to have a definition and just have an overview of what object-oriented programming entails. And just as the name suggests, you can hear we are talking about programming. It is all about developing systems, because in the era that we are in right now, systems have become very, very critical, so that you can be able to speed up the process of inputting and, of course, outputting and processing information. Systems have become very, very important in different business setups, in different organizations, and actually in our day-to-day activities. When you visit different offices and different organizations, you will be served by people using systems. So, object-oriented programming, we'll be talking about different systems that can be developed, and of course we first need to look at just an overview of what this object-oriented programming entails. So we can start with the definition of what is object-oriented programming, and we can say that object-oriented programming is a paradigm or a pattern of programming whereby the solution to a programming program is modeled as a collection of collaborating objects. So, objects usually collaborate by sending messages to each other, and of course, object-oriented programming approach, it is suitable when you are managing large and complex problems. So, let's have an overview of procedural programming versus object-oriented programming, just to understand why is it that OOP wins when you compare it with procedural-oriented programming. And of course, we can say that the major aim of object-oriented programming is to be able to remove some fallbacks that are usually there in procedural-oriented programming. So let's just talk about a bit of procedural-oriented programming, and we can say that procedure-oriented programming basically consists of writing a list of instructions for the computer to follow. And of course, you organize these instructions into a group of what we call functions. And of course, we make use of flowcharts to organize these actions and represent the flow of control from one action to the other. That is for procedural-oriented programming. So, in a multi-function program, many important data items are placed as global so that they may be accessed by all the functions. And of course, each function may have its own local data as shown in our diagram. So let's look at some of the features that are usually exhibited by procedure programming. So what are these features that are usually exhibited by procedural programming? So in procedure-oriented programming, of course, emphasis is on doing things, or it gives more emphasis on algorithms or sequence of events. And of course, another key feature is that large programs are usually divided into smaller programs, and these smaller programs are what we are calling functions. Another key feature that is usually exhibited by procedure programming is that most of these functions usually share global data. And of course, another key feature of procedure programming is that data move openly around the system from function to function. Another key another key feature that is exhibited by procedure-oriented programming is that functions transform data from one form to another. And of course, a another key feature is that procedure-oriented programming usually employ what we call top-down approach in program design. And of course, for the examples that we can give for the procedure-oriented programming, we have C, we have Fortran, we have Pascal, among others. So now that we have talked about procedural-oriented programming, let's go now and look at object-oriented programming. And of course, we are saying that object-oriented programming usually treats data as critical element in program development. And of course, it is able to tie data more closely to the functions that operate it, and it allows decomposition of a program into a number of entities, and these entities, we call them objects. And then build data and functions around these objects. So object-oriented programming, of course, it is based on the concept of objects. You need to think about programming solutions in terms of objects. So we have depicted, we have an image here showing the object 1 and object 2. And of course, we have the functions there and the local data. So let's look at features of object-oriented programming. Which are the key features that normally stand out when you are talking about object-oriented programming? And one of the key features is that emphasis, object-oriented programming pay more emphasis to data rather than to the procedures. And of course, a key thing we have said about object-oriented programming, of course, it is all about being able to think about programming solution in forms of objects. So programs are divided into what we call objects. And of course, we'll be talking about these basic concepts about objects and all these terms as we proceed. Another key feature of object-oriented programming, we can say that data structures are designed such that they characterize the objects. Another key feature of object-oriented programming is that functions that operate on the data of objects are tied together in the data structure. And of course, the other concept or key feature of object-oriented programming is that data are hidden and cannot be accessed by external functions. So we'll be talking about this concept of data hiding as we talk about basic OOP concepts. The other key feature of object-oriented programming is that objects may communicate with each other through functions. So objects basically are able to communicate with each other through functions. And of course, the other key feature is that new data and functions can be easily added whenever necessary. New data and functions can be easily added whenever necessary. And of course, the approach that is used in object-oriented programming, it follows bottom-up approach in program design. So some of the common examples of object-oriented programming, we have Java, we have Python, C#, and of course C++, because C++ will be our area of interest. So now that we have compared procedure-oriented versus object-oriented programming, let's look at basic OOP concepts. And of course, with these basic OOP concepts, once we understand these basic OOP concepts, even when we start now the coding or rather writing the codes themselves, of course it will be easy for us because we will be able to, we will have understood the basic concepts or the basic terms that we'll be encountering in object-oriented programming. So we can say that object-oriented programming simplifies software development and maintenance by providing some concepts that we are going to discuss below. So one of the key concepts is what we call objects. And we have talked about objects in there before. And of course, objects normally represent real-world entities. A real-world entity can be a person or even a thing or even a program. So objects are very, very critical, are very, very critical component that we need to understand, and we'll be looking at maybe common examples of objects. So we can say that objects are the items that represent real-world entities such as a person, a place, or thing in a program. In a program, we can say that an object is a software representation of a real-world entity. So we can say that an object is a software representation of a real-world entity. We can say that objects are the basic runtime entities in an object-oriented system, and they may represent a person or even a place. It could be a table of data. It could be maybe a table of data that the program has to handle. We can say that objects can also represent user-defined data, such as vector, time, and even a list. And of course, when a program is executed, the objects interact by sending messages to one another. So we can continue maybe just so that we can understand the concept of objects, and we can look at examples here. We can have two objects in a program. We can have an object we are calling customer, and the other one we are calling an account. So we are saying customer and account, these are two objects in a program, and this object we are calling customer can send a message to the other object we are calling account, just requesting for the bank balance. So each object contains data and code to be able to manipulate the data. We can also have other examples of objects here. We can have an object like student, and maybe the data could be the name, the date of birth of the student, the marks, and the functions could be, we want to compute maybe the total, the average, and the like. We can also have another object there, person. You can have the name as the data. You can have also the basic pay as the data. And we can also compute salary as a function, and also tax as a function. So just to help us understand what are these, examples of objects. So now that we have talked about object as a basic OOP concept, the other concept we need to understand is what is a class. And of course, these are just the templates for objects. So the templates for objects are what you're calling a class. And of course, an object now is an instance of a class. So a template for objects and an object is an instance of a class. So we can say that a class is a template or even a blueprint representing a group of objects that share common properties and relationships. We can say that, again, a class is a combination of a set of rules which will work in a specific program. And we can say that it contains definition of new data types like fields or variables, or even operations that will perform on the data. And those operations that will perform on the data is what we call the methods. And of course, we'll also have another definition of what a class is. It is just to expound more. We can also say a class is a template for object. We have said that again. And of course, an object is an instance of a class. And once, when the individual objects are created, they will inherit all the variables and functions from the class. So we have an example here of a class and an object there. So we can have a class being a car, and object there, it is either Volvo, Toyota, and the like, simply because we are saying when the individual objects are created, they will inherit all the variables and functions of a class, and we have given an example there. So the other important concept that we have just talked about when we were talking about a class is inheritance. So just like we know the normal inheritance with us acquiring properties and functionalities. So we can say that inheritance is when one object acquires all or some of the properties and behavior of a parent. That is what we call inheritance. So when one object acquires some of the properties or behaviors of a parent, that is what we call inheritance. And we can say that the process by which one class will acquire the properties and functionality of another class is what we call inheritance. So when one class acquires the properties and functionalities of another class, that is what we call inheritance. And we can say that inheritance provides the idea of reusability of code reusability, and each subclass defines only those features that are unique to it. So we can expound more on the concept of inheritance, and you can say that in object-oriented programming, the concept of inheritance usually provides the idea of reusability, and this means that you can be able to add additional features to an existing class without modifying it. And of course, it is possible to derive a new class from existing one because of this concept of inheritance. And of course, the class that is derived will have combined features of both the classes. Hence, the classes are reusable. And of course, we can say that inheritance is the capability of one class of things to inherit capabilities or properties from another class. And you can see we have depicted here, we have the parent, and of course we have child class 1 and child class 2, meaning that this child class 1 and child class 2 is going to inherit the features of the parent. So let's go to the other common or other important concept of object-oriented programming, and it is what we call polymorphism. So polymorphism, we can say that it is the ability of different functions to be invoked with the same name. And we can also say that it is a property by which the same message can be sent to objects of several different classes, and each object can respond in different ways depending on its class. And of course, we can say that polymorphism normally plays a very important role in allowing objects having different internal structures to be able to share same external interface. And this means that a general class of operations may be accessed in the same manner, even though specific actions associated with each operation may differ. And you can see, you have depicted there the concept of polymorphism, where we have the shape, which could be a circle or even a square. The other important concept of object-oriented programming, we can talk about data abstraction. And simply stated, data abstraction, this is the act of representing essential features without including the background details or explanation. So you just represent essential features without showing without providing the background details or explanation. So classes can use this concept of abstraction and are defined as a list of abstract attributes such as size, weight, and cost, and functions can operate on these attributes. And of course, the attributes are sometimes called data members because they normally hold information. The functions that operate on this are sometimes called methods or member functions. So we can also see the concept of message passing, and of course the interaction between objects usually happen through this concept of message passing. So simply stated, we can say that a single object by itself may not be useful. So an application can have so many objects, because we say that the object-oriented programming is based on the concept of objects. And of course, one object interacts with another object by invoking methods, or into brackets functions, on that object. So through the interaction of objects, programmers can be able to achieve high order of functionality, which has complex behavior. So we can say that one object invoking methods on another object is known as message passing. And of course, objects communicate with one another by sending and receiving information, much the same way as human beings communicate with one another. So objects being able to communicate with one another, it is what you are calling a message passing. So message passing normally involves specifying the name of the object, the name of the function, that is the message, and the information to be sent. Another important OOP concept is what we call encapsulation. So encapsulation helps us achieve, or rather be able to implement data abstraction, and we have talked about data abstraction there previously. So we can say that the wrapping up of data and functions into single unit called class is known as encapsulation. And we are saying data encapsulation, actually this is one of the most striking features of a class. And the data is not accessible to the outside world, and only those functions which are wrapped in the class can access it. And of course, we have said encapsulation can be used as a way to be able to implement data abstraction, because simply because it hides the details of the implementation of an object, and it focuses upon the implementation that give rise to the observable behavior. Another key concept of object-oriented programming is what we call methods. And of course, methods are basically, we can simply state them as behavior. And of course, a class can contain many methods, and it is in methods where the logics are written, data is manipulated, and all the actions are executed. So a method, we can say it is simply a behavior, and of course a class can contain many methods. Another key concept of object-oriented programming is what we are calling instance variable. So each object has its unique set of instance variables. An object state is created by the values assigned to these instance variables. Another key concept of object-oriented programming is a procedure. And we can say that a section of a program that performs a specific task, or a section of a program that performs a specific task, we can simply say that is a procedure. And maybe finally, as part of key concept, we can talk about dynamic binding. That is, it refers to linking of a procedure call to the node to be executed in response to the call. So dynamic binding means that the code associated with a given procedure is not known until the time of the call at runtime. So now that we have looked at the basic concepts that we'll be encountering in object-oriented programming, from all those concepts we have talked about, we can look at the advantages, and we can say that object-oriented programming is able to model real world very well, because it is able to simplify the whole process of developing programs. So, of course, with object-oriented programming, programs are easy to understand. We can say that object-oriented programming offers class usability, because you have said already created classes can be reused without having to write them again. And of course, because of that, it is able to facilitate quick development, as parallel development of classes is possible. And another advantage, you can say that programs are easy to test, manage, and maintain. Maybe for the disadvantage, of course, object-oriented programming, of course, designing these programs can be very tricky because of even skills, and of course, at times, coming up with a program can be a bit tricky because you need to have proper programming skills. So we can say for the disadvantages of object-oriented programming is that the concept of classes that we have talked about tend to be overly generalized. And of course, we can say that the relationship among classes can sometimes become artificial. And of course, object-oriented programs design is tricky. And we have said that one needs to do proper planning, and of course you need to do proper design for object-oriented programming. And another key disadvantage, we can say that to program with object-oriented programming, of course, you need, as a programmer, you need to have proper skills. For the design skills, your design skills need to be good. You need to have good programming skills, and you need to be able to think in terms of objects. So you need to model problems in terms of objects. So that in itself become a disadvantage. So now that we have compared procedure-oriented programming and object-oriented programming, we can, and also we have seen the basic concepts in object-oriented programming. We have talked about these objects, we have talked about classes, encapsulation, we have talked about inheritance, we have talked about polymorphism. All those basic concepts in object-oriented programming. We can just have a structure, just see an overview of how how a C++ program look like. Because the best way when you're learning a programming language, you need to be able to write a program. And of course, for you to be able to write proper C++ program, of course, they need to have a particular structure. Otherwise, the syntax need to be correct. Otherwise, your program will not work. You will be generating error messages. So you need to make sure that the syntax is correct, or the compiler will generate error messages and it will not produce the executable machine language. So, of course, we have said that for the next lesson, we will talk about as in what we require for us to be able to program. But for now, we need just to know that C++ is a general purpose, high level, and compiler-based, and object-oriented programming language. And we have expounded more on what we mean by object-oriented programming. And there are many programs that you can develop using C++, like operating systems, we have editors, we have many commercial applications, we have database, we have translators, we have device drivers, we can have PC and mobile games, among the many others. So all these programs can be developed using C++. But for today, I just want to have a small structure, just a general overview of how a C++ program looks like. And of course, with this structure, what is important for us, it is just to understand what we are calling the include IO stream, and of course, the using namespace, the int main, the C out, all these, what they mean in a C++ program. So to explain more on these, we need to understand the first line, what we have said, the include IO stream. This is just a header file library that lets us, that help us to be able to work with input-output objects. So the first line, that is the header file library that will help us to be able to work with input-output objects, such as what we are calling the C out that we will see in line 5. So with this header file, they are able to add functionality to C++ programs. The second line is we have seen in our program there using namespace. So it means if I take you back there, if I take you back here, to the second line. It means that we can use names for objects and variables from the standard library. And of course, the third line, we have a blank line, and C++ normally ignores the white space. So we have the fourth line in our program. And of course, another thing that always appears in a C++ program is int main. This is what is called a function. And of course, it is inside, what is inside the curly brackets will be executed. So we have it here. And of course, we have line 5, what we have called cout. So we normally pronounce it as cout. This is an object used together with the insertion operators. So if you go back to our program here, you will see the insertion operators there. And we are saying that this is an object that is used together with the insertion operator to output or even print out text. And in our example that we have given there, we'll be able to print out hello world. And of course, it is good to note that every C++ statement will end with a semicolon. And of course, the body, what you're calling the int main, could also be written as we are showing there. You can write the body so that you will be able to output hello world. And of course, it is good to remember that the compiler will ignore white space. And of course, when you have multiple lines, of course, that will make the code to be more readable. And of course, the line 6 of our code, the return 0 will add the main function. And of course, line 7, do not forget to add the closing curly bracket to actually add the main function. So that is just an overview of a simple C++ program. So the next thing in the next lesson, we'll be talking about now how to write a C++ program, how we are going to save, and of course, we go through the different programs. Thank you.
These televised lectures supplement our robust online learning going on our MKU online platform. You can view more on our televised lectures via our online platform. We are in a digital era, and Mount Kenya University knows this. The following are the steps to follow so as to complete your online application. Download the application form from the website www.mku.ac.ke. Attach copies of your academic certificates and ID. Pay the application fees via M-Pesa pay bill number 270988. Your ID is the account number. 2,000 shillings is the charge for a postgraduate. You can also deposit in the bank accounts provided on the website. Then email all the above to apply@mku.ac.ke.